Welcome to our 5-part series of video tutorials about conducting pilot experiments to gather data for industrial scale system sizing. In this second episode, we will talk more in details about one key parameter of cross-flow membrane filtration, the cross-flow or circulation flow velocity. It may sound obvious that this parameter is key, but you would be surprised how little attention it often gets at the development stage. First things first, why is this parameter important? Because it is what differentiates cross-flow filtration from dead-end filtration. The driving force of the permeate through the membrane is the difference of pressure between the two sides of the membrane, called the TMP or transmembrane pressure. Resistance to the permeate flow is a combination of the ceramic layer of the membrane itself, fouling in the membrane, and a buildup of a clogging layer on the feed retentate side of the membrane. The whole purpose of having a cross-flow is to erode continuously this clogging layer and get as little resistance to the flux as possible. Depending on your pilot unit, you may have one feed pump and one dedicated circulation pump, or only one feed pump. The first configuration provides more stability, but the two types of pilots are workable. Another important factor is that this circulation flow is significantly high. It often accounts for up to 90% of the power consumption of the filtration unit. Feed and CIP pumps account for the remaining 10%. Therefore, it is definitely worth optimizing the circulation flow rate. How to optimize the circulation flow? First of all, by selecting the right membrane geometry. For smaller channels, the necessary circulation flow rate can be up to 2 times smaller than that of wider configurations at any given speed. So it is important to identify the limit of use for the different geometries involved. Then, by studying the influence of the circulation flow on the permeation flow rate. For that, refer to the filtration curves we developed in the first video tutorial at different circulation flow rates. Novacep can help you in defining an adequate range of circulation flow rates to be explored depending on your application and membrane geometry. Do not hesitate to contact our specialists.